Hello and welcome to our continuation of the Physics 2020 QCAA paper. This is now paper 2, and we're going to start off with question 1. Explain why an object with mass cannot travel at the speed of light in a vacuum. So given this question is only worth 1 mark, we'd be looking for, a simple explanation. So the simple explanation is, I'm going to put it as dot points. It's probably worthwhile to think how you would phrase your answer for the exam. So an object with mass traveling at the speed of light in a vacuum is impossible. And now the way to think about it, it's impossible to accelerate an object up to the speed of light because it would take an infinite amount of energy to do so, and we don't have an infinite amount of energy. So I would write my statement as it's impossible and along the lines of to accelerate a mass up to the speed of light. And then due to infinite, I'm just going to shorten it here, infinite energy required to do so. Now, what would further solidify or conceptualize your answer would be starting to think about why do you need an infinite amount of energy? And the fact that comes in is we use a factor or a formula known as Lorentz factor in a lot of our special relativity physics. And Lorentz factor is L is equal to 1 over the square root of 1 minus V squared over C squared. And we use Lorentz factor in time dilation as well as length contraction, as well as also momentum. And this is where we start thinking about the energy required to move an object, a stationary object, up to the speed of light. You have to put energy into a system. And so we're thinking about the energy beforehand of an object with mass, with no velocity, would be 0. But the energy afterwards would have to be infinity. And the way that you can conceptualize this is I recommend getting out a graphing software and graph Lorentz's factor here and see how it plays a role in changing your special relativity calculation for momentum. So my recommendation would throw in y is equal to 1 over, do root 1. Now set your speed of light to say 1, so you can see it a lot easier on your graph, and then x squared on top. And what you'll note is it turns into quite an exponential function. So here my green line is come along as it becomes into our positive values, and as it gets close to 1 is our theoretical, in this instance, speed of light, whereas our speed of light is 3 times 10 to the 8 meters per second. But you see, as it gets to here, it spikes right off and heads towards infinity. And then if this y factor now becomes infinity and you're plugging that in to your now special relativity calculation for momentum, you're multiplying that by infinity. And that's going to lead to a near impossible amount of it. Well, not a near, an impossible amount of energy to move a mass at the speed of light. And so that's another way to conceptualize and put into, a formula your answer to this question.